onward and forward. So at this point, you should have most of your quality control values calculated. I think the trickiest thing to calculate is probably the relative difference. Remember, when you're calculating relative difference, to compare the cells, the appropriate cells to each other, the 1-to-2 ratios are the ones that you're comparing, the 1-to-10. So assuming that I did it correctly, here's the values that I got for deionized water. I can make that a little bit bigger. Right, for 0.01 molar calcium chloride, right, these are the values that I got, right, doing essentially just copying and pasting that formula. Here's the values for the CCV I got, right, and then here's the values for the recovery of the standard reference soil down here for calcium chloride. For deionized water, right, they're not quite as good, but still fine. And then 1 molar KCl, we do not have a standard reference soil that has values for that. So that's why we didn't calculate that. So where you see a percent relative difference of 0, that just means that you had great agreement, right? And we're rounding to the nearest whole number. So if we showed more than 1 decimal place, then you would see a value for it. Okay. So that's why we have it like that. Are there any questions about this? So here's where we're going with this. What I'm going to have you do, and it's going to be due tomorrow, but don't stress about it because you'll have time to get most of this done in class today. So I'm going to have you each individually turn in a quality control table that summarizes the quality control parameters that you've just been calculating and some other ones. It should be set up something like that, right? Those are the different things that we did for quality control. Tell me what the matrices are. So we're going to organize it by matrix. Yeah. Fantastic, right? So we got deionized water. We have
0.01 molar calcium chloride.
Whenever you have molar, right? What do you got to do?
Alice.
Right? Isn't that right, Shannon? Yeah. No, I said that. You have to check your revisions that I just graded. Zach left your track changes up. I saw some comments that you made about me. Gotta be careful. Okay, so we're going to organize it like this, right? That, like that, and this is just going to summarize it. Okay. So we have percent slope. Percent slope is not necessarily broken out by matrix type, but on the deionized water tab, you can see that the range goes from like 97.3 to 98.9, right? And that's going to be the same for every single one, right? That is to say, for every single matrix, 97.3 to 98.9. Okay. And then we have some parameters. We have all the other parameters broken out by matrix. So you can easily put down the percent slope for everything. Percent RCCV, you have that for each matrix. We just calculated percent relative difference. So you just put the ranges there. You calculate a percent R for the SRS, and then we have a percent relative standard deviation that we still need to calculate. But as you know from last time, when we calculated percent relative standard deviation, right, it was kind of a pain in the butt, right? Like we had to insert the average and then the standard deviation and then divide the standard deviation by the average multiplied by 100%. So this time we're going to have jump do it because it's going to be much easier. And I'm just going to show you another tool that is convenient and easy to use, right, called the tabulate function. But it also depends on how we input the data. Okay, so if we go to the JMP, Los Osos, and Holland worksheet, and maybe before we go there, do you have any questions? Okay, so we go to this. What we're going to do is we're going to join a couple cells, and we're going to use a function in Excel called concatenate. And concatenate just means join. Okay, to do that, though, I want to kind of leave this worksheet the way that it is. That is to say that it has a soil column and a method column. So I'm just going to, and you can do this any way you want, but the way that I'm going to do it is I'm going to copy this worksheet and just put it next door to it. Right, so I'm going to put it right in front of the JMP Costa Rica. Okay, so it's there now. And after I've done that, I am going to create a new column that's going to be after the method column. So I'm going to insert a column right here. And I'm going to call this a combination of soil plus method. Okay, soil plus method. And then I'm going to use a function called concatenate. And concatenate just combines whatever cells that you want to combine together. I'm going to do it a kind of a slightly different way than just simply putting them together, because I'm in my formula, I want Excel to put a space between Holland A and DISP. Okay, so I'll show you what that function looks like. But it's going to be equals concatenate. And parentheses. And it's going to be cell D2 and E2 that are combining. And then I'll just fill it down. So I'm going to select D2. And then I'm going to put a comma, quotation marks, and then I'm going to hit the space bar just once. And then quotation marks, that's just telling Excel that I want to put a space between what's in D2 and then what's in E2. Okay, and then close the parentheses. All right, so give that a shot. Fill that formula down. It's all together. So what this will do, right, is it groups all your soils by method and by soil horizon. And for each method and soil horizon, we have 4 duplicates, right? And so it would take us a little bit of time to insert the formula into Excel and calculate the relative standard deviation, because there's not a function to do that easily. So we can do that in JMP fairly easily. So go ahead and copy those 2 columns of data. And then open up JMP and open up a new data table. And after you've opened up the data table, I would save it as something, first of all, to start out. And then go ahead and put in paste with column names. Okay. And remember that after you've pasted with column names, we have nominal data and we have numeric data. The nominal data must be identified as such. And the way that we identify the nominal data, or the way that JMP identifies nominal data, is with the red histogram, right, before the title. And the numeric data, it's a blue triangle. If it's not like that, you can double click on your column heading and you can change the name of it if you want to, but for data type, you can select a different data type, right? But it should be character for soil and method. If it's not, then make sure it is, and then hit apply, and it'll apply that to the whole column. If it's same with the pH, it should be numeric. If it's not numeric and continuous, then you can change it to numeric and continuous and then hit apply. Okay. Questions so far? Okay. So then what we're going to do is we're going to do analyze and tabulate. Okay, and analyze and tabulate gives you a bunch of descriptive statistical terms that you can have JMP calculate for you or determine for you. And it keeps your variables included. So we want to figure out what for pH, what if we wanted to, what the mean standard deviation range was for these things. It doesn't have relative standard deviation, but it does have the coefficient of variation, which is the same thing. So CV and percent RSD are identical to each other. Okay. So go ahead and just like play around with it a little bit and don't stress about it too much. Like I'm just going to play around with it because I forget every time I use it, like which is the best way to put my data so it demonstrates what I want it to. But it's so fast that it doesn't really matter. So I'm just going to drag one variable there. I'm going to drag another variable, the pH variable here. And what it's calculating right now is the sum for all those values. And I don't really like the way that looks because it extends on and on too far. So I'm just going to start over and I'm going to put soil and method on the vertical column and pH on the horizontal. So pH I'll put up here and soil and method I'll put right there. So that's a little bit easier to see. So by default, it's determining the sum of all my pH values. So of the 4 replicates for each of these matrices in each of these horizons, it's giving me those data. But what do we really want? We could want average, but we don't need it. What do we really want? Relative standard deviation, which is the coefficient of variation, right? The CV. So I'm going to grab CV and I'm going to put it right here. And that doesn't really do it. Right? So I didn't put it in correctly. So I'm going to click undo. Then I'm going to grab it again and try it a different way. I'll try that. See how it changed from the whole long rectangle of all the data to being right next to just the sum. So I'm going to try that. And that's actually what I want. Okay. So you could leave the sum. I don't need the sum, but so you could put the CV right in there instead, which is a good way to do it. Let's see here. Yeah, so you can put the mean right in there if you want that better. But what we really want is to break up the coefficient of variation by matrix. And the way that it is right now is it's not like super easy. It's not super user-friendly, but it's user-friendly enough that we can make it work. So what we need to do now, and what I encourage you to do is do this with someone sitting near you, is like take all the 0.01 molar calcium chlorides that are there and figure out what the range is of the CV. Take all the DI water, including saturated paste, and figure out what the range is in CV, and then do the same thing for 1 molar KCl. I mean, like another way that we could do it, I guess, maybe this would be easier. Yeah, let's try this. So let's go to the tabulate here, and we can save the script to the data table. So we keep it, we don't have to do it again. Okay. And then let's see. I know that I can take this data table and save it. Did anyone see that on here? Maybe save as. Oh, on the tabulate. Yeah, there we go. Make into a data table. There we go. Okay. So once it's there, I am going to copy it and see if it's easier to work with that in Excel. Edit. Copy with column names. And then we'll go back to Excel. Try paste. Glad you. All right, so that might be easier for you. I don't know if it is or not. But what's the goal that you need to do now? Separated by matrix, right? So take a moment, separated by matrix. And maybe if you did that and then, well, if you alphabetized it, it wouldn't work either.
Oh, things like dragon.
Is this faster than just looking at it? I'm just separating on matrix, right? Because that's what we need. We need to know what the range of coefficient of variation is by matrix.
So calcium chloride, calcium chloride with the 2 and 2 to 10, probably put those together.
Oh, is we're gonna go back to this first spreadsheet here, the JMP, Los Osos, and Holland. That one. And we're gonna create a figure very similar to the figure that we created for cation exchange capacity. All right, so what it is it's going to compare all of our data together, including the method, soil, and pH data. So in order to do that, I want to have soil, method, and pH, all those data selected. Sorry, copied, and then paste it into a new jump data table with column headings, and then make sure that the columns have categorized the data properly. All right, so you should have your data imported into jump, and we're going to use the graphing tool just like you did before. So it's graph and then graph builder. And we want to compare pH. So our dependent variable is pH. That's going on the y-axis. Our independent variable is method. We're going to put that down on the x-axis. And then our legend is going to be soil. So it's going to group all of our soils together within each of those different methods that are there. Does that make sense? So I'm going to just drag that over to the legend there. And then it's going to put my data in a way that's not very easy to see what's going on. So I'm going to create columns that look like that. And of course, like with any figure that we create, we want it to be as visual as possible and as easy to visualize trends as possible. So it makes the most sense, right, to look at these data in terms of the lowest pH to the highest pH, or opposite, right? Highest pH to lowest pH. You can do it whatever way you want, but I'm gonna choose to go from low to high. Since that is impacting the x-axis, right? That is to say, we're going to change the order of our x-axis. We need to change the axis settings, right, for the x-axis. And so the way that we're going to do that, and I'll just pause for a moment. Is everyone good? All right, pretty easy. Freddie, that's all right. You're okay? And remember, if you mess up, doesn't matter. Just start over, right? It doesn't take long. Just a few clicks, right? You're good? All right. So we're going to change the order of our x-axis methods. And what do we see here? What in general has lowest pH? Potassium chloride, right? Because that is the highest concentration of salt. So that is putting the highest concentration of exchangeable acidity into solution. So I want, and then what else do we expect? 1 to 2 to have a higher, or 1 to 10? That's a trick question. Should be about the same, right? Because as you dilute, you're adding more salt. So that is putting more exchangeable potassium into solution at the same time as you're diluting. But it would make sense to do 1 to 2 first and then 1 to 10 after, unless there's a huge difference. So I'm going to go to the x-axis, and when it becomes the hand, that means that I am selecting that axis. So I'm going to right click on that and go to edit value order, and then select the ones that I want and just move them where I want them to be. And probably for saturated paste versus 1 to 2 in DI versus 1 to 10, which one should be the lowest pH? Saturated paste, exactly right. Why, Shane? Dilution factor. Lowest dilution factor, right? As you dilute the thing that you're measuring with water because there's no salt in there. So the thing that we're diluting is protons or hydrogen. So saturated paste should be, and it is, and we didn't talk about it when we were looking at our data, but it was the lowest. So I'm going to move that just below 0.01 molar calcium chloride in the 1 to 10. And then I'm going to hit apply. And okay. See, that looks good. So then, what you can do from here is just work on some formatting. I'll remind you of a few things. You want the graph itself, right, to be white. You don't want it to be kind of gray or this color over here. So we'll change the format of that in just a sec. You're going to create a caption, so we want to get rid of that title. There, I'm going to move my legend into the figure there. I also want to insert some error bars. So for the error interval, I'm going to say standard deviation like that. And then I want to change the font size of some of my axis labels so that I can see them better so that they stand out more. But the first thing I'm going to do is I want to make sure that all this area is white when I save it as a image. And I want to make sure that all my font is black. So I'm just going to go anywhere in here and right click and go to show properties. And the background color here is going to be white. The text color is going to be black. And that's what I want to do. Get rid of that. And then what I want to do is I'm going to change the size of the axis labels. I'm going to make them bold and 12 for both of them. And then go back to that one and I want to rotate it left so it looks better like that, I think. And this one, I'm going to do the same thing. Okay. You could change the numbers if you want here, but I'm just going to leave them the way that they are. And then I'm going to save it. I'm going to save the script, right, to that data table. But I think, yeah, Hugo.
You said bold and 12.
That's what I did. Yeah. So I need to go back. I want to go back to, actually, I can go to the graph builder and save the script to the data table. And it's just going to call it graph builder. If you want to call it something else, you can. So now it adds that there. And then I'm going to save this worksheet here, data table, because I forgot to do that before. And then I'm going to go back to my figure. And I'll just leave it like that for a minute. Do you have any questions? Yeah. Yeah. So if you go, so notice my cursor here, if I go down to my axis, it turns to a hand. And if I right click there, then I can go to edit value order. Yeah.
I'm having an issue where when using the UI, I don't know if it's because of the resolution of my screen, but I'm not seeing like the apply buttons pop up.
Okay.
So
Let's
like
see.
when I'm trying to make the
is the analyze tool, right? So you go to the analyze tool and we're going to fit model. And we want as our response variable pH. And as our model effects, they're going to be soil and method. So add those down there. And then I want to select them again. And do you remember what we got to do so that they're together? Yeah, we cross them, but it's a similar process. So we cross them, right? So that just means that soil and method are going to be together. Both those variables are together and comparing pH at the same time. Lee.
Oh, yeah.
So I select both of them together with the control key and then push cross. Yeah. Right. And then you run it. And you get this. And what we're mostly interested in, and I guess like I didn't have to do soil and method together because we're not going to use those data. But I want the soil and the cross soil and method. So I'm going to click on that arrow there and I'm going to go to LS means Tukey HSD. And then we get this crosstabs report, which I don't want. So I'm going to get rid of the crosstab report. And what is interesting here, what we need to look at is which ones are significantly different from each other and which ones are not. So how would you interpret the crosstab or the connecting letters report there? Yeah, Elijah.
Letters, it's whichever ones that have the same letters have statistically significantly similar meanings.
Exactly right. So anytime there's letters that overlap, right, within one of those values, they're not different from each other, right, at a p-value of 0.05. Right. Yeah.
That's if they share one similar letter or the whole sequence.
Any one similar letter. So anytime one of the letters, right, is shared, then it's different. So when you see data like this, right, where you have a lot of connection between your column means or your population means, sometimes it's easier to put an asterisk above a column where it's significantly different from the values around it, just because it's kind of laborious to put 5 letters next to each other above a column, right? We're not going to do that. I just wanted to remind you of the test, but I'm not going to have you do that for the figure that you're creating. So as a reminder, right, for the thing that I'm going to have you turn in tomorrow, it's the summary quality control table for which you have all the data. I already have an assignment on Canvas associated with this, and then this summary figure that we just created. And you need an appropriate caption for each, okay? And it's individual, so you each need to turn that in. So since we did this, what I'm going to do now is I'm going to attach this to my data table by saving the script. And it's going to say fit least squares, and I'll just say fine. And if you wanted to, right, you can click on that arrow right there and you can save the connecting letters table if you wanted to do that. I don't want to do that, but you could.
I somehow missed the step how you open up the turkey table. I just have to put these squares in this table.
Okay, so the way that you do that, right, is the soil times method one. You click on that arrow right there, the red arrow, and you go to LS means Tukey. That's my pleasure. So I can go back and go back to this one. And now what I want to do is save this as an image. You can save it however you want, but I'm going to save it as an image. So I can paste it into, oh, wait a second. I'm going to go to export maybe. Yeah, export. And I'm going to save it as an image. And then just put it wherever you want it. And there's probably some stuff about it that you need to fix, like this stuff at the top right there. I'm gonna get rid of that. And then this down here, which says each error bar is constructed using one standard deviation from mean, which you do want in your caption, right? But since you're gonna put it in your caption, then we'll get rid of it right there. So I'm just gonna edit this by cropping it. Going to save that like that. Okay. Love it. All right. Questions? Comments, concerns? Freddie, how do I export it? Good question. So what I would do is I would go to File, Export, when you're looking at your graph. And then I picked image, and then I'm going to call it, the format is JPG. I think its default is PNG. You good? Yeah. Okay. So what we'll do right now is take a break for the 5 minutes, and then we'll come back together. All right. If you have any questions about this while we're taking a break, just let me know. And I'd be happy to answer any questions that I can. That was easier, right, this time?
That's